Hello, so for today's video, this is all about one-way ANOVA or analysis of variance for independent samples. By definition, the one-way ANOVA or analysis of variance is used to determine whether there are any statistically significant differences between the means of two or more independent groups. So our situation is a professor wants to determine if a certain delivery mode differs in test results of 5 groups of students. The total number of items is 40 and each group have 20 participants. So we have here 5 groups or treatment: the group A, group B, group C, group D, and group E. So each treatment or group have 20 data samples, the total of 100 data samples in all. So we already pasted the 5 treatment or group in this. So in treatment 1 we have 20 samples, and treatment 2 also 20 samples, and in treatment 3 20 samples, and in treatment 4 20 samples, and also in treatment 5 we also have 20 samples. So the significance level is set to 0.05. So these are the calculation of the result. So the F ratio value is 0.27781, and the P value of ANOVA is 0.891671, and the result is not significant at P is less than 0.05. Okay, so to sum up the results, here is the narrative discussion. Objective: is there a significant difference in the test results of between groups? Null hypothesis: there is no significant difference between groups of participants. Significance or parameters: significance level is set to 0.05 and CI is 95%. Normality test based on p-value. So group A, the p-value is 0.98458, normally distributed. For group B, the p-value is 0.81688, normally distributed. Group C, 0.88057, normally distributed. For group D, 0.55713, normally distributed, and for group E, 0.89687, normally distributed. Results: Result 1, the mean of group A is 31.45, the mean of group B is 32.05, the mean of group C is 32.5, the mean of group D is 30.75, and the mean of group E is 31.75. So the group C is the best group and group D is the least group. Result number 2, ANOVA p-value. The ANOVA p-value is equal to 0.891671. Interpretation: hypothesis in null form will be accepted, therefore there is no significant difference in the performance of each group. Data analysis: the given dataset had been tested with one-way ANOVA for independent samples, since each group will consist of different participants or respondents. Each group had been tested with Kolmogorov tests of normality with a result of computed p-values such as 0.98458, 0.81688, 0.88057, 0.55713, and 0.89687 for Group A, Group B, Group C, Group D, and Group E respectively. These values suggests that the datasets in each group were normally distributed since their computed p-value is greater than 0.05. It was also found out that the group C has the largest mean and group D has the smallest mean among the 5 groups. This means that the group C is the best group and group D is the least group. On the other hand, treating the two datasets with one-way ANOVA for independent samples, it yields a p-value of 0.891671, which is greater than 0.05. Since p-value is greater than the significance level, the null hypothesis will be accepted. Therefore, the performance of each group were not statistically different.